Trading is about optimal decision making in the face of uncertainty. No doubt this requires a combination of knowledge and experience, but if we're going to take a swing at a pitch, are we going to take a swing at a low probability ball? No, we're going to take a swing at a high probability one that we can knock out of the park. And that's exactly the purpose of this tool. In this video, we're going to build my earnings event trading dashboard. This is going to allow us to observe historic earnings events, analyze the implied volatility crush effect, and assess the overall temperature of the market to see if we're observing something similar in an earnings event right now that we can possibly trade, and help us assess whether or not we should take a swing at that pitch. I'll give a demonstration of this tool in a moment, but if you're unfamiliar with the general strategy of implied volatility crush, I have a video dedicated to the topic. I will leave a link to it in the description below, and the trades that I place in that video were informed using this tool. I highly encourage you to code this tool from scratch so you can work on your own extensions. But of course, if you just want access to the project source code so you can run the tool right away, I will leave a link to the project source code in the description below. I will also post it to the Quant Guild library on GitHub, where you can find all of my Jupyter notebooks and associated YouTube videos, along with all of the source code for my quant builds. Moreover, these videos certainly take a lot of effort to create, so if you'd like to help support the channel so I can continue to create videos just like this one, please like, comment, subscribe, share. It helps me out tremendously. It is greatly appreciated. And if you'd like to master your quantitative skills, check out quantguild.com. Maybe you come from a background in business, economics, computer science, physics, and aren't too sure where to get started on your quant journey. Maybe you're an aspiring quant or a working professional looking to sharpen those quantitative skills for a technical interview. In any case, Quant Guild is for you. We have over 90 quant lessons in math, probability, finance, an adaptive practice engine that scales with your skill level so you can progress to more and more difficult topics with gamified rank-based progress, interview questions with fully worked solutions, trading games coming soon, courses from A to Z in math, coding, probability and statistics, data science, and more, all from the ground up. And all that's included with Quant Guild membership. And you can get started right now for free. So if you'd like to help support the channel and master your quantitative skills, check out quantguild.com. Without further ado, let's get started with a demonstration of the tool that we're going to be building in this video. Of course, this tool is going to require data. To access the data necessary for this tool, we're going to be using Interactive Brokers. I'll leave a link in the description below if you'd like to get started with Interactive Brokers. I've been trading with them in an algorithmic capacity for over 10 years at this point. I highly recommend them and their API. They are the only broker that I use. So how does this dashboard work? Let's suppose that you just downloaded my source code and you've run it in Python and you want to connect to Interactive Brokers. Well, what you're going to have to do is you are going to have to come over here to the upper right hand corner of your trader workstation and click configure. Once you click configure, you're going to head on over to API, head on over to settings, and you're going to need to enable ActiveX and socket clients, disable the read-only API if you want to be able to place orders from your system, and of course verify the socket port here is in fact 7497 for paper trading or 7496 for live trading. Now, a very important note in all of my quant builds is the volatility must be in terms of daily units if you're looking to scale by the square root of 252. Now, you can choose whether or not you scale your volatility units. That's going to be entirely up to you. But I know some people have reported crazy volatilities in the hundreds, and that's because you're using the wrong volatility unit. So if you go on over to volatility and analytics, you can set your vol units to be either daily or annual. So once you've set them correctly here, you can hit apply, okay. Now we can head on back over to my event trading dashboard. We can successfully connect to Interactive Brokers, and now we can analyze an earnings event. So what I'm going to do is I'm going to use the event that I traded earlier this year on NVIDIA. So here I have NVIDIA, I have the earnings date of August 27th, and the days to expiration for the particular option contract that I was looking at. So now, if I hit Analyze IV Crush, what's going to happen is I'm going to get a whole bunch of information and some pretty cool charts down below. So let's go over exactly what it is that I'm looking at. We're trying to assess whether or not we want to take a swing at a pitch. What I mean is we're trying to assess whether or not we want to take a short Vega position in NVIDIA. So what am I looking at here? Well, I get the current metrics, the stock price, the VIX, and the current implied volatility. And below, I'm going to get an IV crush analysis for the event that I entered here. This is what has happened previously. I can see the pre-earnings implied volatility, the post-earnings implied volatility, and the percentage of IV crush. Since this is negative, if I had a short Vega position, I would have in fact made money. And if you go back to my video on implied volatility crush, you'll see, yeah, I made a couple $100 on NVIDIA. So let's take a look at the spot versus strike analysis. We're going to assume that the closing price is the spot of our straddle. This is very useful in the context of assessing whether or not there was too much volatility post the earnings event to capture that Vega profit. And if we take a look, the post earnings spot price, the average the next day was 180.53. That is nowhere near the volatility that was implied by the move in the straddle contract. And if we take a look at the straddle pricing, we can look at the P&L. We can see the pre-earnings call and put value, the post-earnings call and put value, and of course the change in value and the change in the overall straddle value. And because it was negative, if we took a short position, then we would in fact have made money, capturing that implied volatility crush effect. And that is exactly what we see in the charts below here. In the charts below here, what do we see? We see that implied volatility was this green line, and then post the earnings event the next day, it dropped all the way down here. It dropped from what? 43.5% all the way down to 32.1%. We can capture that volatility crush. And of course, the price did not move nearly at all. It went from what? 181.6 to 180.53. We are very able to capture that implied volatility crush effect, capture that profit, and then exit our position. And of course, we can use that knowledge and experience to look for similar opportunities in the future. Now, keep in mind, trading is a game of expected value. Nobody knows what the outcome of your pitch is going to be. You may strike out. You may knock it out of the park. Nobody knows. You must size your bets correctly, and you must execute upon the general strategy effectively. This goes into the idea of optimal bet sizing, acting optimally in the face of uncertainty. I have plenty of videos on this topic. If you're going to trade in a discretionary capacity, if you're going to trade to try to accumulate wealth, you must act with positive expected value. You cannot make outsized trades on any one trade just because you think this looks similar to what has happened. No, that's not what it means to accumulate expected value. So this is a tool. This is a tool to assess what has happened and in what type of market climate. You can see the VIX around the earnings date was relatively stable. It didn't move all that much. It was below 15. But then what happened actually a few days later, this was around the same time as the rates discussion in August. If you're unaware of what's happening in the broader market, then you are going to be subject to much worse odds in some sort of trade that you're trying to profit from. So if you just execute a trade without any concern for the macro regime, the overall market temperature, then the probability of you making out on that trade is going to be completely different than if you are aware of those dynamics. So when we look at something like this VIX chart, this is informing us of the overall market temperature. Was it flat? Was it increasing? Was it decreasing? What is the general market saying in terms of uncertainty? You can see after the discussion on rates, yeah, the VIX spiked up, right? It spiked up 1.5 points versus the week before during the earnings event for NVIDIA. It had no necessarily impact on the outcome. So this is a very useful chart to help us also assess the current regime that we are trading in. Of course, there are a ton of ways that we can enhance and improve this event trading dashboard. I have videos on Markov chains and hidden Markov models for identifying some sort of latent regime. And if we incorporate those states directly into this tool, we can help ourselves identify states that have a higher likelihood of capturing that implied volatility crush profit. In other words, we can enhance our edge by integrating those tools directly into this dashboard. So I certainly encourage you work through building this dashboard on your own. I certainly encourage you check out those videos and see how you can combine those tools to help enhance your edge. In any case, we're now ready to get started building this project from scratch in Python. All right, let's get started with this quant build. I got VS Code open. I got my Copilot AI LLM off. We're going to be writing all of this code the old-fashioned way. Be a shame if we learned something. So let's go ahead and start with importing everything that we are going to need. So we're going to need tkinter for our UI. So I'm going to say import tkinter as tk. I'm going to need some things from tkinter. I'm going to need ttk, message box, and scrolled text for our log. I'm going to import threading for our IB API, import time so we can handle those requests from the server, import pandas as PD to handle the data. I will import numpy as MP to again handle the data. For our plots, I will say import matplotlib.pyplot as PLT. I also need to be able to update the figures on the user interface. So I'm going to import matplotlib.backends.backend.tk.ag, and I will import figure canvas tk.ag, or I should say from backend import figure canvas tk.ag, and then I will say from ibapi.client. We can import eClient. This is going to allow us to make requests to the server. And of course, we need the server to be able to respond to us with those requests. So I will say from ibapi.wrapper, import eWrapper. And that is where the server will respond with those requests. From ibapi.contract, import contract. This will allow us to create specific security requests. So for our earnings event, we're going to query data for, say, NVIDIA, Apple. This is how we will tell the server which security to request data for. Then I will say from date time, we can import date time and time delta. This is going to help us with our plots and formatting the dates. Now I also need to import warnings, and I will be suppressing those warnings within ignore. Filter warnings, ignore. I'm going to be using Python 3.10 for this. Let me switch to my global, or I'll use 3.12. No, I'll use 3.10. Okay. There we go. Warnings, filter warnings. Great. All right, terrific. So these are all of our imports. Now we need to go about creating the main class that is going to interact with the Trader Workstation server. That is Interactive Brokers. This is how we're going to request the data and store the data from the server. So I'm going to create class IB app, and this is going to take both the eWrapper and the eClient as a parent class. So this IB app class is going to be responsible for asking the server for data via a request and then managing the response from the server. So I'll say def init self.connected will default to false because of course we don't start connected to the server. Then I will say historic data is equal to an empty dictionary. That is where I'm going to store all of the data from the server. And of course, we need to initialize the superclass. So I will say eClient.init, and I will use this as the eClient and this as the wrapper. So effectively what I'm doing here is I'm saying, hey, this IB app class is going to be a subclass, an implementation of the wrapper, which receives data from the Trader Workstation, and an implementation of the client so it can make requests. All right, that is the purpose of this class. Now we need to handle errors from the server. I'm going to implement an error function. Def error, self rec ID, error code, error string, and of course just arbitrary arguments. We will say if the error code is equal to 76, and we have fractional share in the error string dot lower, then we can go ahead and ignore. We don't particularly care if we have a fractional share error. We're trying to request this historical data. Okay, so we can print, of course, this error with the error code. Make this a formatted print statement. Print the error code. So we have the error code and, of course, the error string. That is, if it's not a fractional share error, we're going to print it. And if we have args, then we will print the additional information. Cool. So that is the error function. This is the function that is going to be pinged from the server if we have an error in our request or if there's an error in some sort of response. This is where all that information will go. And of course, we also have the request ID. We could also print the request ID that caused this error. Maybe I'll do that as well. So we have rec ID. Then we have the error and the error message. All right, cool. Now we need to create a new function to tell this class that we've successfully connected to the server. So what's going to happen is, again, this class is responsible for managing server requests and responses, but we don't start off connected right away. At the bottom of this application, we're actually going to call the connect function to make that connection request. But until we get there, we need a way to mark that flag as connected once the server does respond with data. And to do that, I'm going to say def next valid ID. And in this case, I'm going to create this next valid order ID function, self order ID. And when I connect successfully to the server, it's going to respond with the next order ID that I can use. So it's going to hit this function, next valid ID. That means that if this function is called, I'm going to set connected to true, because the only case that this is called is when the server responds with a valid order number. Now, I could also use the connect ACK function. In fact, I encourage you to look at the IB API documentation and see if you can implement that specific function on your own. That's a very nice exercise, and it's very simple. You just have to find specifically in the eWrapper what that function is called, and then instead of putting self.connected true, print connected to IB here, you can move it over to that connect ACK function. But in any case, this will certainly work. This is where the server has successfully responded to our client here with data, so we will mark connected as true. Now we need to manage a historical data request. To manage a historical data request, I'm going to create a new function, def historical data. I'll say self rec ID bar, and in this function, I'll say if rec ID is not in self.historical data, then what does that mean? If it's not in self.historical data, I need to create a new key value pair. This is a dictionary, and I want to store the data based on the request ID. In other words, if I'm requesting NVIDIA price information or VIX information or implied volatility information, each request is going to have a unique ID, and I want to store that in this dictionary. So what I'll say is self.historical data, the key is going to be the rec ID, and the value is going to start as an empty list. Now I can populate this empty list with data. I'll say self.historical data, I'll find that rec ID, and I'm going to append the bar data that I requested. I'll say date is going to go to bar.date. I'll say open is going to go to bar.open. High to bar.high, low to bar.low, close to bar.close, and volume to bar.volume. So this historical data function is going to be responsible for creating the key value pair in the dictionary. Again, in this IB app class, we have this dictionary. We're going to create the key value pair for the request ID. This could be for the implied volatility or the price information. And then we're going to store the bar.date, bar.open, the open, high, low, close, and date information, of course, with the volume in the historical data dictionary. And the key is going to be that request ID. Now, when the historical data request is complete, we have a historical data end function. This historical data end function is going to have a request ID, a start, and an end. And effectively, we're just going to print historical data received for rec ID, and we will just put the request ID. This will help us figure out if we maybe have an error in our query for historical data. So for example, if our data request is for request ID 1, and we don't ping this historical data end request, and instead request ID 1 goes to this error function, we know there was an issue specifically with that data request, and then we can handle it accordingly. So if there's no issue, then we're going to successfully add all the data to the dictionary, and it's going to hit this historical data end function after all of this is done and we've successfully queried all the data. And that's what we're going to use for our charts. So that is essentially everything that we need for this IB app class, for this particular controller. Again, this is responsible specifically for receiving data from the server and making requests to the server. It's a place that the server can interact with our client from. That is precisely what this IB app is. Now we can focus on the earnings trading dashboard itself. For the main user interface of this application, where we're kind of going with this is we're going to have a main window. That's going to be our TK Inter application. And within the window, we're going to have a whole bunch of sections for labeled frames. And that's going to allow us to populate each section with the appropriate metrics, the appropriate widgets for that specific section. So for example, we had the current metrics, right? The current spot price, the current implied volatility, so on and so forth. Then we had the IV crush analysis for the date range that we entered into our application. Of course, above that, we had our connection panel, so on and so forth. So that's where we're heading. We need to build a class capable of producing that user interface. To do that, I'm going to say class earnings trading dashboard. And in the constructor, I'm going to take a root window. So I'm going to be able to, wherever I create this earnings trading dashboard UI, I'm going to provide it a new instance of a window, and that window is going to be populated by this earnings trading dashboard. Okay, so I'm going to say self.root is equal to root. So in this class, whenever I refer to the root window, I'm referring to that main window that I provide to the constructor in this class, wherever I create the instance of this class. I'll say the title is Earnings Trading Dashboard, specifically for IV Crush analysis. We could also do this for maybe some earnings announcement drift, so on and so forth. That could be another project down the line if there's interest. I can set the geometry, that is the height and width of this window. I'll make it 1600 by 1000 by default. And that's going to be the main frame of the application. Now I need to go about creating variables for the data that is to be stored in this user interface. So this is going to be the main window. Now I need data storage. So I'm going to do self.stockData is equal to none. Self.vixData is equal to none. Self.IVData is equal to none. Self.earningsData, or earningsDate rather, is equal to none. And then self.ticker is equal to none. And this is all going to be provided by both the user and the server. So all of this is going to be updated dynamically. For the connection specifically, I'm going to say self.IBApp is equal to IB app. This is going to be an instance of the class we created up here. This will allow us to create the initial connection. Okay, so within this earnings trading dashboard, I'm also going to have a connected flag dedicated to specifically this user interface. So this self.connected flag is pertaining to this earnings trading dashboard class, the instance of this class that we create. And of course, this connected flag pertains specifically to this class and that instance. Okay. As far as option pricing parameters go, we really just need a risk-free rate, and we can just leave this as 5% for right now. That should be fine. And we're also going to want to define a twin axis for, of course, the price and the implied volatility. So I will define this as none for now. And now I'm going to call self.setup UI. This is going to be a function that is going to be populating the root window that we provide this instance of our earnings trading dashboard when we create it. So now we need to build this setup UI function to populate the root window. So let's do that, right? But before we do that, we need to create some helper functions. So I'm going to start by creating a function that's going to create an equity contract. I'll say create equity contract self.symbol. And what I'm going to do is I'm going to say contract is equal to contract. This is from Interactive Brokers API. And I'm going to say contract.symbol is equal to what? It's equal to the symbol that we give this function, .upper. The security type, I'm going to fix as a stock. The exchange, I am going to say is smart. And the currency is US dollars. And I will return that final contract after we build it within this function. Okay, terrific. So this is really only going to be for equities, right? But now we also need to create a contract for the VIX, right? So the left chart in our application was the stock price path and the associated implied volatility. We can get both pieces of information from a historic data request using the contract that we create from this function. So the user just has to give us a symbol. Then the rest of the parameters are fixed and we can request that data. But what about the VIX data? How do we get the VIX data? Well, we need to create a VIX contract. I'll say def create VIX contract self. We don't need a ticker here. This is going to be essentially the implied volatility of SPX options, right? That is precisely what the VIX measures. So what we're going to do is use that as a temperature, a gauge of market temperature. And that can help us make decisions in a forward-looking sense to assess whether or not in a backward-looking sense we saw a similar regime and similar dynamics in some sort of implied volatility crush trade. And of course, we can also extend this, if you've seen any of my previous quant builds, to regression analysis, trying to actually quantify this idea of a volatility risk premium. That is the fact that volatility is systematically overpriced. We can use regression analysis, and we've built a dashboard in the past. I'll leave a link to that quant build in the description below if you'd like to check it out. But if you would like to quantify the edge more systematically in that way, we can do that. And that uses two different volatility regimes, a low and high regime, based on an intersection of the regression line. It's a very cool project. Highly recommend you check that out. And it's a good way to extend this project, especially in the context of Markov chains and hidden Markov models. So in any case, we want to get the VIX data. So I'm going to say contract.symbol is equal to VIX. I will say the security type is an index, right? It is not an equity. I will say the exchange is, of course, SIBO. And the currency is USD. Then I will return that contract. So that is how we are going to get the equity contract and the VIX contract. We can just call those functions, and we will get the correct contract object to pass to our IB app, which we can then send to interactive brokers to receive data. Now we need to create our function to set up our UI. The first thing we want to do is establish the main frame within the root. So I'm going to say the main frame is equal to ttk.frame self.root, and I'll throw a little bit of padding on it just so it looks nice, and I will give it a grid layout. So I'll say for this grid layout we have row 0, column 0, and I will make it sticky in TK West, TK East, TK North, and TK South. All right, so that is the placement of this particular frame in the root of our application. Now let's configure some parameters about the grid weights. I'll say self.root.column config 0 weight 1 and self.root.row configure 0 weight 1. And then mainFrame.column configure 1 weight 1. MainFrame.row configure 8 and weight 1. All right. And it'll be more apparent why we're giving these rows and columns the weights that we are once we build out each individual section. But bear with me, you can always tinker with these if you like. Now let's start by creating each label frame so that we can create each section of that user interface. So for starters, we need to create the connection frame. The connection frame is going to be a label frame, so I'm going to call it conFrame ttk.labelFrame, and I'm going to place it in the main frame. I'll give it the label of interactive brokers connection, and I will give it some slight padding. Okay. I'm going to give it a grid layout here. Conframe.grid row 0 column 0. That is how we're going to place it. We'll give it a column span of 2. We will make it sticky tk.west, tk.east, and I will give it some padding on the y axis 0, 10. More than sufficient there. Now I'm going to add a whole bunch of labels and inputs. So I'm going to have a label for the host, a label for the port, and then of course buttons for connect and disconnect. To accomplish this, I am going to create a new label object. I'm going to place it in the connection frame. The text is going to be host. Now notice I'm not storing this in a variable, right? The connection frame has a label frame that is being stored in this conFrame variable, which will allow me to place other widgets in it, like this label, right? But here, I don't need to save this label's information. It just needs to exist in the connection frame. So I have the host. I'm going to place it, right? So effectively, I want you to notice here, right? This conFrame is a widget, ttk.labelFrame. That is in fact a widget. To place it, I need to call some sort of pack or grid layout like I have here. And effectively what I'm doing is I'm skipping this step entirely. And instead of doing this step where I do assignment and this step where I call the grid or pack, I'm just going to do it in one step and have it exist in the conFrame. So I'm just going to say .grid. I'm going to place it in row 0, column 0. And I will give it some padding on the X because, of course, this is the host label. And now I can create the host input field. Self.hostVar is going to be the host variable for the string for the input. So I'll say tk.stringVar. The value is going to be 127.0.0.1, our local host. And the form is the exact same situation as the label. It doesn't matter if we have a variable to track that particular object. We just need to place it on the frame and have it be back connected to this string var. So when I create this entry, I'm going to place it in the connection frame. I'll say the text variable is equal to self.hostVar, and I will make its width 15. That should be plenty of room. And then I'm going to place it where? Well, the same row as the host label, row 0, but column 1. And I'll have padding X be 0, 10. Okay? And the same is true with the host as is the port. All I have to do here is change the label from what? Host to port. The value here from the local host to 7497, the default port for interactive brokers. I'll change the host var to port var. I'll update the port var here. And of course, I need to change the rows and the columns here. So I want to put this in column 2. So the port label will be in column 2. And that would mean that I want the text field to be in column 3. So now I have the host label in column 0, the host input in column 1, the port label in column 2, and the port entry in column 3. Fantastic. Now we can create our button. I am going to say for our connection button, self.connect button is equal to ttk.button con frame. Text is equal to connect. And command is equal to self.connect IB. All right. We're going to have to create that self.connect IB function, which is going to call the connect function in the earnings trading dashboards IB app object instance. That is an instance of this class that will allow us to interact with the trader workstation. Now I need to add it to the frame, right? I need to call a grid or a pack. So I'm going to say self.connect button.grid, and I'm going to throw it in row 0, but column 4. This will be all the way at the end. I'll have some padding on the X, 0, 10, and I'm going to do the same thing with the disconnect button. All right, so I'm going to say self.disconnect button is equal to ttk.button. I'm going to throw it in the connection frame. The text is going to be, of course, disconnect. The command here is going to be self.disconnect IB, which we also have to create, and the state is going to be disabled. All right, because of course we don't want to be able to disconnect if we are not yet connected. Should be disabled. And then we're going to need to, of course, give it a layout. So I'm going to say self.disconnectButton.grid. This is going to be next to the connection button. So we will put it in row 0. We will put it in column 5. And that's going to do it for this connection label frame. This is everything that we need. This is going to be in columns 0, 1, 2, 3, 4, 5 all the way across. Host label, host entry, port label, port entry. Then, of course, we have connect and disconnect buttons. And the entries are going to be linked to the associated string variables. So when we actually need to pass information to the server, the connect IB and disconnect IB functions, they will be accessing these self.port and self.host variables. Now we need to create the label frame for the earnings analysis. I'm going to say earnings frame is equal to ttk.labelFrame. And I'm going to say, let's throw this in the main frame, right? We're no longer working in the connection frame. We have our main frame, right? The root of the application, the main frame. We have our connection frame at the top. Now we're going to go into the earnings analysis label frame. So we're going to say this is going to exist in the main frame. This is going to be the earnings analysis setup. I'll give it some padding. I'll give it a value of 5. And now I need to give it a layout. I'll say grid row is equal to 1. Because remember, we're moving down now. We have our connection frame. Now we're moving down to the earnings frame. This is going to be still in column 0. We'll give it a column span of 2. And we will say that it's sticky to the west and to the east. And we will give it some padding on the y-axis. Okay, so that is our earnings frame. Now we need to create the labels and the entries for the ticker, the earnings date, and the days to expiration. What does that look like? Well, it looks just like these labels and entries that we created above. So I'm going to copy this. Effectively, I'm copying the label for the port variable, and the entry. I will copy it, come on down here, and I'm going to paste it and make some modifications. So I'm going to paste it here. And what we're going to do is you can press Shift Tab to back tab out if you have some sort of tabbing issue. Now I'm going to modify this so that it works with our earnings frame. So let's start with this ticker, right? Instead of being in the connection frame, where should this be? Well, it should be in the earnings frame. What row should this exist in? Well, this is a new frame, so we're going to have it exist in row 0, column 0. 5 padding on the X is totally fine. The default value we will leave as NVIDIA, and we will use the default earnings date as well for the demonstration that I gave you at the start of this video. And for the string var, I will call it ticker var. The entry is also going to exist in the earnings frame. Instead of self.portVar, I should be using self.tickerVar. And the width itself, I guess this should be width, not widget, width. This should be 10, 15, totally fine either way. And the location is going to be in column 1. Okay, so effectively what we have here now is we have our label, our entry, and the variable that tracks the data in that entry. That is the purpose of these 3 lines of code, specifically for the ticker. Now we do have to go up here because it looks like I did make a mistake in the host and port entries. I call this widget. This really should be width. This should be width, and this should be width. Okay, cool. Now that that's all resolved, we can move on, rinse and repeat with the date and days to expiration for our option. So effectively here, we're in row 0, column 0, row 0, column 1. I can copy this label and entry, and then what? Do the exact same thing, but now instead of for the ticker, I will do it for the date. This is going to be the earnings date. This is going to exist in the earnings frame, so we're all good there. Where should we place it? Well, we should place it in column 2, right? This is going to be next to the ticker entry. And then instead of a ticker var, I'm going to have a earnings date var. And the default value will be 2025 08 27, the earnings date for NVIDIA. The entry that tracks the earnings date variable that the user enters into the form is not going to be ticker var. It's going to be earnings date var. A width of 10 is totally fine. Maybe we can make it even a little bit bigger if we like, a little bit wider. And what column should this exist in? Column 3. That is where this entry will exist. Padding X, totally sufficient. And we're all good with the earnings date label and entry. And now we can do the exact same thing for the expiration of the option. So days to expiry, grid, we will say column what? Column 4. The default value we can put as 30. Instead of earnings date var, what tracks the days to expiration, we could say days to expiration var. And then we can link that to the entry here. Days to expiration var. And of course, we need to put this in column 5. Very cool. So that should do it. And of course, we can tinker with the width here, depending on our preference for the user interface. But this is everything we need to effectively receive the input from the user to figure out what we should be fetching from the server in terms of pricing and implied volatility data. We're going to be querying a range of data around this specific earnings date. That's going to be our objective. So now that we have all of the information we need from the user, we can create a button to effectively analyze the event. And what I'm going to do is I'm going to create a button called self.analyze button. I'll make it equal to a TTK button. I'm going to put it in this earnings frame. Remember, we have the main frame of our application. Then we have this connection frame at the top. And of course, we also have this underneath the connection frame, the earnings frame, where the user is going to enter all of the earnings date information. So in there, we also have this analyze button. And this analyze button is going to have the text of analyze IV crush. The command that we have to create is self.analyze IV crush. So we're going to have to create that function ourselves, and we're going to want to leave it as disabled. State is equal to disabled, at least until we successfully connect. We don't want to be able to request an analysis of IV crush if we're not connected to the server. I'm going to place this where? Row 0, column 6. That is the column right after our entry for days to expiration. And that's going to do it for that section. Now we're ready to move on to the current metrics section. So this section is the inputs for the application to fetch the historical earnings event. Now we're ready to move on to query for the current metrics. So for the current metrics section, it's really nothing crazy. We just need some labels and to update the labels once we fetch the data from the server. So this is going to be the current metrics section. Again, keep in mind what we're working with here. We have the main window, the connection frame, the earnings analysis inputs frame, and now we have the current metrics frame. So this metrics frame is also going to be, of course, a label frame. And in this label frame, we're going to place it in the main frame. The text is going to be for the frame current metrics. The padding we will say is 5. And for the metrics frame, I'm going to place this where? Row 2, column 0. I will make the column span 2 so it has enough space. I will make it sticky to the west and sticky to the east. And I will add some padding on the y-axis just as before. And that is going to be my label frame for the current metrics. Now, all I need to do is create a few labels for the stock price, the VIX level, and the current implied volatility. So I'm going to say TTK label. I'm going to throw this in the metrics frame. And in this metrics frame, I'm going to have the text stock price. And I'm going to place this in row 0 and column 0. I will give it some slight padding on the x-axis, and that will do it. And that will do it for the label. Now I need the label variable that I can update with pricing information. So I'm going to say self.stock price label. And keep in mind here, now I'm actually assigning this to the label object. That way I can update the text. I'm going to place this in the metrics frame. Initially, I'm going to have no text until I query data. I will make the font Arial, I'll make it 10, and I'll make it bold just to distinguish between the label for the stock price and the actual stock price I query. And of course, I am going to pack this. I will say, or not pack this, I'll give it a grid layout. I'll say stock price label.grid. Gonna throw it in row 0, throw it in column 1, give it some padding on the X. I will say 0 and 20. And now I'm going to do the same thing, but for the VIX and the current implied volatility. So I can actually just copy this and paste it twice. I'll do it one at a time though. And I'll say, yeah, we need to create it in the metrics frame. Instead of a stock price, right, we are going to do the VIX level. And I will place this in what? We have column 0, column 1. We'll place this in column 2. And then instead of stock price label, this should be what? VIX level label. Then I will say VIX level label.grid. And I can leave NA until I can populate it with data. And of course, where am I going to place it? I have the original label for the VIX. Put that in column 2. That means that the actual value that we query from the server should exist in column 3. Side by side, right? Column 0, column 1, column 2, column 3. And then we can do this exact same thing, but for not the VIX, implied volatility. I'm going to put this in column 4 then. Instead of the VIX level label, what will I have? I will have a current IV label. And I am going to use that current IV label in this grid layout for column 5. So that is going to effectively be my current metrics section. Now we're ready to move on to the IV Crush analysis frame. The IV Crush analysis frame is just going to contain the pre-earnings implied volatility, the post-earnings implied volatility, and the percentage of implied volatility crush. So this is going to look roughly the same as the current metric section. So for this specific earnings event, I'm going to create a new frame, a new label frame here, and it's going to exist in the main frame. Again, we have our main frame, our connection frame at the top, our earnings frame, then our current metrics frame. Now we have our IV Crush frame. This is an IV Crush analysis of the earnings event that we've already entered in our form into the user interface. So this exists in the main frame. The text for this label frame will be IV Crush analysis, again, for that specific earnings event. The padding will be 5, and the frame will exist in what row? Grid row 3, column 0, and the column span we will leave as 2. Of course, sticky on the east and west, so that there is horizontal room and it's sticky to the sides correctly. And the padding Y, of course, we will leave the same as before. Okay, so now what do we need to do? Well, we need to effectively, instead of displaying stock price, VIX level, and current IV, we need to display the pre-event IV, the post-event IV, and the percentage of IV crush. I'm going to copy these 3 labels or I should really say these 6 labels, the stock price, the VIX level, and the current IV, and of course the variables that we're using to store the correct information. I'm just going to copy those and I'm going to paste them right underneath, because all I got to do now is change each one of these such that they fit in the crush frame and they display the pre-event IV, the post-event IV, and the percentage of IV crush. So I'm going to take the crush frame here. I am going to put all of these in the crush frame. That is going to be my first step here. I put all of these labels in the crush frame. Once I've done that, I can just change the labels. So instead of stock price, I'm dealing with the pre-earnings IV. Instead of VIX level, I'm dealing with the post-earnings IV. Instead of the IV crush, or instead of the, I should say, instead of the current IV, I'm dealing with the percentage of IV crush. Okay, now I need to change the variable names that are tracking the data that are to be displayed within the label. So instead of the stock price label, I should have a pre-IV label. and that is going to be in this grid layout here. Now, what's the cool thing? Well, I don't need to change the grid layout for these labels because these exist now in which frame? They don't exist in the metrics frame like they did here. These exist in the metrics frame that we defined here, and it goes from what? Row 0, everything's in row 0, but we have column 0, column 1, column 2, column 3, column 4, column 5. Well, that is effectively what we're going to do here in this new frame, crush frame. So we don't have to touch the grid layout at all. We just have to fix the labels tracking the variables, or the variables tracking the labels, and of course the text. So we fixed the text. Now we're fixing the variables tracking the labels. So we have pre-IV label. Now we need post-IV label. And of course, we need IV crush label. Fantastic. And NA is totally sufficient initially. And if we wanted to, we could change the foreground color of the IV crush percentage to red. So it kind of indicates that crush effect. So I'm going to change the foreground color of this crush label to red, just specifically to handle that idea, to essentially signify that there was some sort of percentage decline after the event occurs. Very good. So that is going to do it for the IV crush analysis label frame. And we're making really good progress. So now we can create the frame for the spot versus the strike. So I need to create, again, a new label frame, spot strike frame, ttk.label frame. I'm going to throw this in the main frame. The text is going to be spot versus strike analysis. Give it some padding. And I'm going to give it a grid layout. And remember, this is going to be a new frame in our main frame. So we have our connection frame, we have our earnings setup frame, we have our current metrics frame, we have our IV crush analysis frame. Now we have this spot versus strike frame. This is going to exist in row 4, column 0. I will make the column span 2. I will again make it sticky to the west and to the east. And I will make the padding the same on the y-axis, so it looks like every other label frame. Okay, well, what are we displaying here? We're displaying the strike price of the straddle. We're going to assume it's closed spot, which is relatively reasonable for the position that we would take. We can also make this a function of an input. So if you wanted to extend this so that the user could input a specific spot or a specific strike price for their straddle, I certainly encourage you to do so. In any case, we're just going to treat the close as the strike price. Then we're going to look at the pre-earning spot at close. So those will be equivalent. And then we're going to look at the post-earnings spot, the next day average, to see if the implied volatility indicating the price move for the earnings event was over or understated. Effectively, this is going to tell us, hey, was there too much volatility for us to capture in the post-earnings event move? Did we sell insurance and did somebody cash out on us? Were we able to collect that profit from this overstatement of volatility or not? Okay, well, to do this, I'm effectively going to do the exact same thing that I just did for the pre-IV label, post-IV label, and IV crush. I'm going to copy these three, and I'm going to paste them in this new frame. And now I'm just going to modify everything for this spot versus strike frame. So where does this exist? It doesn't exist in the crush frame anymore. It exists in the spot versus strike frame. So I'm going to go ahead and make those changes there. The labels are going to be what? We have strike price. We have the pre-earning spot, the close. And we have the post-earning spot, as the next day average. Cool, so now the labels are updated, the frame is updated that we're placing this information in. The grid layout is still sufficient, right? Because we are placing it across the columns. We have one row and multiple columns for all these labels. Fantastic. Now we just need to update the labels that actually track the values of these items. So we have the strike price label. We have then the pre-spot label. And of course, we have the post-spot label. All right, very good. So now we can move on to the option pricing frame. This is where we're going to put in the at-the-money straddle pricing and P&L, pre-earnings event and post-earnings event. So this is going to be the options pricing frame. I'm going to create this as a new label frame. So I have option frame is equal to ttk.label frame. This is going to be in the main frame. The text will be at the money, straddle pricing, and P&L. The padding, we can make it the same as the others. We'll do 5. This frame is going to be what? Row 5 now, beneath the strike versus spot label frame. Connection frame, earnings frame, current metrics. Then we had the spot versus strike. Now or the IV, then spot versus strike. And now we have the option pricing frame in row 5. So row 5. Again, we'll put this in column 0, column span 2, so it's wide enough. We'll make it sticky to the east and west. And we will give it some padding on the y-axis, 0, 10. Okay, well, now we need to include a whole bunch of labels for all of this information. So we're going to do this by copying and pasting all of this label information and making changes, because we're going to create effectively 2 rows of information. So I'm going to copy these 3 labels, come down here, paste them, and work off of these 3 like we did last time, but now with this options frame. So we don't operate in the strike frame anymore, so I'm gonna replace, and replace. Instead of the strike price, what do we need to display? The pre-earnings call, right? That's the call leg of our straddle. I need the pre-earnings put. That is, or I'll do pre and post-earnings call. Post-earnings call, and of course the call change. So the change in call value. So that's going to be my first row of data effectively. I have the pre-earnings call value, the post-earnings call value, and the call change in value. Now I need to update what? Well, the rows and columns are totally cool because we're operating in this new label frame. Now we need to update the variables tracking the label values. So I have this pre-call label. Then I have this post-call label. And I have this call loss label. And of course, this call loss label here. So this is going to be pre-earnings call value, the label, and the value for the label that we're tracking, the post-earnings call label, and the value for the label we're tracking. Same thing with the call change in value, and we're going to assume that it is, of course, a loss here. Now, I should say, when we've been copying this information over, the foreground is staying as red whenever we've copied that label over for the percentage IV crush. So it's up to us whether or not we want to include it. So for the percentage IV crush, I think it's reasonable. For the post-earning spot, it could be reasonable if it declines, but we don't know what that's going to be. We could make it conditional on the data, but I'm just going to remove it altogether from that specific label, the post spot label. And I'm also going to just remove it from the call change label, even though it could, of course, be negative. It's going to depend on that IV crush effect. So where we have it up here is probably reasonable in terms of the decline of implied volatility, but everywhere else subject for discussion. Likely we should make it conditional on what we actually observe. So in any case, right, that is pretty much all of the call information. Now we just need to do it for puts. And the only thing that we have to change between these three labels is the row and the fact that they're puts instead of calls. So it's actually really easy. I'll just copy these six labels, these three chunks of code here. I'll paste it. And instead of operating with what? Calls, I'm operating with puts. So I have a put. I have a put. I have a put change. And then instead of a call loss label, what is this going to be? A put loss label. This is going to be a post, not call label, a post put label. This is a pre-put label. Effectively, we're just translating everything from calls to puts here, and the columns are actually going to align perfectly. So right now, we have calls going across. We have, the call label, call label, call label, call label, call label going across. Now we're doing the same thing with puts. We just want to put that information one row down. So instead of the put labels being in row 0, I'm just going to put them in row 1. And then, or I'll put them in row 0. No, sorry, this is row 1. Yeah, everything's in row 1. Row 1, row 1, row 1, row 1, row 1, and row 1. And that will be the call and put values pre and post the earnings event. So now we can actually look at the straddle totals. So we can look at the straddle total value pre-earning and post-earning, and of course the change in value, and the value of a long and short straddle position. So let's go ahead and do this now. Effectively, this is the exact same thing as we just did with the puts. We're just going to do it with the straddle value. So now instead of row 1, everything's going to exist in what? One row down, row 2. So we have the call information, the put information, and now we have the straddle information. So this is going to be pre-earnings straddle, post-earnings straddle, straddle change, pre-straddle label, should be lowercase, straddle. So we have this idea of the pre-straddle label. We have the post-straddle label. And of course, the straddle loss label after the event. All right, great. So this right now shares all of the correct columns with the call and puts, but of course it's in the same row as the puts. We want to put it one row down. So instead of row 1, this will be row 2. And then this will be row 2. This will be row 2. This will be row 2. And this will be row 2. And this will be row 2. So effectively, right, the only thing that we've really done is we've created this options frame. We've created these label values and labels for pre-earnings, post-earnings call, and the change, the overall change after the event. The same with the puts, just below the calls, and then the same with the straddle, which combines both the call and put position, and that'll be below the puts. Now we can add P&L analysis. What does the P&L analysis look like? Well, we'll add it to the option frame. And all I'm going to do is I am going to I'll add another row, and I'll make it 2 separate columns. So this is going to look a little different than the previous rows because the previous rows and columns were symmetric. Now I'm just going to do it with the long straddle and the short straddle P&L. So I'm still going to copy and paste these 2 labels. The only difference here is now I'm going to place them in separate spots. I'm going to put this in row 3, column 0. And I'm going to put this in row 3, column 1. This will exist in row 3, column 3. So there's a little bit of space. And then I will put this in row 3, column 4. That should be fine. And now I'm going to increase the column span. So that it spans 2 column widths. And then I need to change all of this information. So it's placed now correctly in the options frame, but instead of post earnings straddle, this is the long straddle P&L. And then this is going to be the short straddle P&L. The label as NA is totally fine because we need to wait for information from the server so that we can price it using the Black-Scholes equation. Now I'm going to call this the long P&L label. Long P&L label. And I'll call this the short P&L label. This will be the short P&L label. Awesome. And now we're ready to move on to the Greeks frame. So this is where we are going to look at the pre-event delta, the change in delta, the pre-event vega, and the change in vega. At this point, we're almost done with the user interface, and we can then begin to go about building the functionality. So for this Greeks frame, right, we just need to create a new label frame. And this label frame will exist in the main frame, of course. This is going to be the Greeks analysis. The padding is going to be 5, just as before. We will place it in row 6, column 0. We'll give it a column span of 2, make it sticky to the west and east. Pad Y, we will do 0, 10. Fantastic. Now we need our pre-earnings delta, post-earnings delta, and the delta change. This follows the exact same format as everything that we've had above here, with the pre-earnings call, the post-earnings call, and the call change. So I can just copy that, just as before, and I can paste it down here. Now I'm working with the Greeks. So I have pre-earnings delta, post-earnings delta, and of course the change in delta, the delta change. The columns that they exist in are totally sufficient. It's the exact same layout that we had for the change in call, the change in put, the change in straddle value. Now we can do it for delta. So instead of pre-call label, this is pre-delta label. Pre-delta label. Then we have post-delta label. Post-delta label. And we have the delta change label. Very good. And the grid layout is totally fine, but where do these currently exist? We're currently placing them in the option frame. That's no good. We have all of the call, put, and straddle information in there. We want to put this in the Greeks frame. Greeks frame, Greeks frame, Greeks frame, Greeks frame, Greeks frame. Very good. And we're going to do this exact same thing, but with the vega next. So the vega is, again, this is the exact same situation for displaying the vega. We're just going to be placing it on the row below. So the columns remain exactly the same. We're just fixing it to be row 1. That's the row beneath row 0. Row 1, row 1, row 1, row 1, row 1, row 1. These now exist, these vega labels. They exist in the Greek's frame in the correct spot, but we need the correct variables to keep track of the information. So instead of pre-delta label, we have pre-vega label. Instead of post-delta label, we have post-vega label. And of course, we have the vega change label. Wonderful. And that's going to be everything in our Greeks section. So effectively what we've done here in this user interface so far, and of course we're going to have to build a section for the status and the plots, and then we're going to be all wrapped up. But effectively we have the main text sections for the user interface here. We have our connection frame. So we have our main panel. At the top, we have our connection frame. Then we have our earnings analysis frame where we enter the date, we enter the expiration, the ticker, the current metrics of the ticker that we entered in the current market, the IV crush analysis section, the spot versus strike change, the options pricing section, and we also have the Greeks frame. Okay, so that's going to allow us to analyze the model and the model values before and after the earnings event. All right. So now what we're going to want to do is we're going to want to create a status section along with our text frame for the logger so we can receive information updates from our application. So this is going to be the status. I'm going to call this the status frame. Make this a label frame. Throw this in the main frame. We'll call this status. Give it a padding of 5. Of course, this is going to have a grid layout just as before. We'll throw this in we're on row 7 now, I believe, if I'm not mistaken. Yep, we put the Greeks frame in row 6. We're on row 7. We want to give this a column span. So a column 0, a column span of 2. We'll make it sticky to the west and to the east. And of course, we want to give it padding on the y-axis. Okay. Now we just need to add the text for the logger to this section. I will say self.statusText is equal to scrolled text, and I will throw this in the status frame. I will give it a height of, let's say, 6 and a width of 80. You can tinker with this to make it whatever you would like. And I will also give this a grid layout. So we will say status text.grid. Throw this in row 0, column 0. We'll just place it directly in the center of this status frame. And of course, we will make it sticky to the east and west, so it has that horizontal room. Of course, the status frame, I will say column configure. And I will give column 0 a weight of 1. Of course, that's just going to contain the scrolled text for our logger. Now we can create our frame for the plot. And this is going to be the last frame that we actually have to create. So all we have to do now is create this plot frame. So I will call ttk.labelFrame. And I'm going to place this in the main frame. This is the bottom. So this is the last subframe in our main frame. Of course, this is going to say Ivy Crush visualization. We get a nice visualization of what's going on. Padding 5. And the plot frame, I will give it a grid layout. Row, I will put it in row 8 now. Column 0. column span, I will make it 2 just as before. And I'm going to make it sticky to everywhere, north, south, east, and west. So tk dot west, tk dot east, tk dot north, and tk dot south. Cool. All right. So now we can configure the columns for the plot frame. I'll give column 0 a weight of 1. I will give row 0 or row configure row 0 a weight of 1. And now I can create the actual plots for this section. So I'll say self.fig is going to contain what? Axis 1 and axis 2. So we have the figure, we have axis 1, axis 2. This is going to be equal to plt.subplots. This will have 1 and 2, and I will make this a fig size of, and of course you can tinker with your figure size. I'll make this 16 and 6. That looks good. And then we need to create the actual figure canvas that we are going to be drawing these on. So I'm going to say self.canvas is equal to figure canvas tk ag. This is where we're going to place the figure and of course the plot frame. Then I can call self.canvas.get tk widget, and I will say .grid, and we will place this in row 0, column 0, and I will make this sticky, of course, to west, east, north, and south. So effectively all we're doing here is we're creating that last label frame for our plots. So that last frame, and we're going to be creating, just as we did before, creating this label frame, placing it underneath all of the other frames that we created with the associated metrics. We'll give it some weight in the column and row space, and then we'll create the actual figure and the axes from PLT subplots. Then once we have our subplots that we can draw data on, we can create this figure canvas tk ag object here, which takes the frame that we're going to plot on along with the figure. And that figure is created here from our PLT subplots. And then I am going to place it. So we get the tk widget. So I say canvas.getWidget. That is literally how we display it. We're going to say .grid, row 0, column 0, and we'll make it sticky everywhere. So as we expand, minimize, expand, whatever, it remains tight to the application window there. So that's actually going to do it for our user interface. We're now ready to move on to the core functionality of this app. So this is where things get fun, right? We can actually start to build some functionality here. Let's start by building a simple function to log messages to the text area that we created in our user interface. So I'm going to say def log message, self message, and I'm going to say timestamp is equal to datetime.now. I'm going to format it as hours and then minutes and then seconds. And I'm just going to insert this to the end of the status text. So I'll say self.statustext.insert at tk.end. So all the way at the bottom, we will insert the timestamp and whatever message we have from this function. And I'll also do a new line. I'm going to want to say status.text self.statustext.c tk.end. Essentially, every time I log a message, I don't want to be stuck having to scroll down, right? That's what this .c function is going to do. It's very useful, and I know I'm always going to have white space at the bottom because whenever I log a message, I have this new line character. You can remove it if you like. You'll never have white space at the bottom, but that's how I like to know I'm at the bottom of my logger. So in any case, I'm going to call self.root.updateIdleTasks to update that UI. Yeah, that looks good. Cool. So that's our logger. now we need to create a function to connect to interactive brokers. I'm going to call this function defConnectIB. This is what matches our button that we created above. So when we click that button, it's going to call this function. I'm going to try to get the host from the host variable that we created. I'll try to get the port variable from the port variable we created, but check this out. What is the port variable? The port variable is a string var. Port needs to be passed as an integer to interactive brokers. I'm going to say int to cast the input to an integer. Self.log message. Connecting to IB at host and port. Fantastic. Now I'm going to create a new function herein called connectThread. And this is where I'm actually going to try to run the connection. So I'm going to say try self.ibapp.connect. So remember, we've already created an instance of the IB app in our dashboard. We've already done that in the constructor right here. I can use the eWrapper, or not the eWrapper, the eClient to request a connection. And I'm going to request it on its own thread. So I'll say .connect, host and port from the user. I'll give it a master client ID of 0. Self.ibapp.run. Totally cool. See if this works. I'm going to accept a general exception as E. And I will just self.log message. If there's an error, I will say there's a connection error. And I will print whatever that is as the general exception. So this is the function that we're going to implement threading for. We're not just going to call this directly, right? So what we're going to do is we're going to use this with threading to attempt to create a connection. So I'll say thread is equal to threading.thread. And I'm going to say target is equal to connect thread. Daemon is equal to true. So we will continue. And I will say thread.start. All right, so hopefully it connects. Let's wait for a connection. I will say for I in range 100, if self.ibapp.connected, keep in mind, this is not the connection flag in our user interface. This is from the server. It's responding to the IB app implementation in our event trading dashboard. So it's literally the server that is telling us if we're connected or not here. Okay? That is precisely what's happening. So if we're connected, try to get the server version. I'll say server is equal to self.ibapp.server version. And if the server version is not none, so we've received the server version, and the server version is greater than 0, really should call this server version. So if the server responds with a version and the version is non-zero, then we can break, we can accept, and pass. Within this loop, we can just call a time.sleep. Cool. So if we end up with a connection here, then we no longer have to sit through this for loop, right? That's what we're saying when we break effectively here. If the server does connect on this thread, because right, we're running this thread. The target's going to be this function. And as we continue through, right, we're going to run this loop and wait. And if as we're waiting, we end up connecting, this loop breaks and we just continue to move on. Now we need to handle the case where we do connect and where we don't connect. So if we do connect, then that flag will be triggered. I'll say try server version is equal to self.ibapp.server version. If server version is not none, just as we had above, and server version is greater than 0, we can enable everything in our application. Self.connected is what? It is now true. The connected flag in our user interface. The server here has effectively responded with, yeah, we're connected. So that's what we're going to do. We're going to tick connected therein. Self.connect button. We need to make that disabled. We don't want to be able to connect while we're connected. Self.disconnect button .config. We need to make this state normal. We should now be able to disconnect. We should also now be able to analyze our IV crush. And I want to log a message that we have successfully, that's a lot of S's, successfully connected to IB, server version, and then I'll just throw in the server version. Just for our logger. Okay. Else, I want to log what? That there was an issue. Connected, but server version unavailable. Right? Because that's effectively what we have here. We've connected. We tried to get the server version. And we have an issue with the server version in this else block here. Okay. This accept block is very similar. We're going to accept an exception as E. And effectively what I'm saying here is what? There's a connection, but a server check failed. So we'll say self.log message. We have connected to the server, but server version check failed. And I'm going to put in the exception that we observe. And I'll make this a formatted print statement. Great. Else what? Else we did not connect. Log. Failed to connect to interactive brokers. Good. And of course, the overall exception is what? Try. Accept exception as E. Self.log message. Failed to, or not really failed, we get a connection error. And we'll just log the exception that we observe. So that is going to be the connect function. What about the disconnect function? It is much simpler, right? Here we're creating a thread, we're passing through, we're ensuring that we connect. Once we connect, we're handling the state of our user interface, so on and so forth. What about the disconnect function? Well, it's as easy as disconnect. Disconnect IB self. I will try to self.ibapp.disconnect. That comes directly from the E client. Now I will say self.connect is equal to false. I will say self.connect button. This is me updating all of the UI. Config state is equal to normal, right? I want to be able to connect again. I don't want to be able to disconnect, so the state is going to be disabled. I don't want to analyze volatility if I'm disconnected, so I'm going to disable that as well. And I'm going to want to clear everything. So I'm going to create a function to clear all of the results that I've analyzed if I tried to. And I will also log that I am disconnected. Great. If we have any sort of exception, I will log it as such. Good. And it's really as straightforward as that. It's a lot easier to disconnect than it is to connect. We're just going to be turning everything off. Self.connect, I think that should be self.connected. Make sure we use the correct flag up here too. Yeah, we did. Self.connected. Okay. Great. Let's clear all of the results now. We'll create a function to clear everything. Okay. Scroll on down. Def clear analysis. Analysis. Results. I will say self.ax1.clear. Self.ax2.clear. Very easy from matplotlib. Thank you very much. If self.ax1 twin is not none and we have our implied volatility data, right? I am going to try to remove it. I will accept an error and pass. I will get an error if there's nothing to remove. Otherwise, self.ax1 twin will be equal to nothing. I am clearing everything. I do not care if it exists. I'm going to redraw the clear canvas. I will say self.canvas.draw. And I'm going to update all of the labels, all of the information in our risk metrics, in our IV crush, in our option pricing display, and in our straddle display. So we have quite a few things to update here. Self.stock price label .config, and I'm going to make the text equal to NA and the foreground equal to black. So really all this is just updating the text in our user interface to remove all of the data that we queried. That's what this clear function is doing. So I'm going to copy this .config because it's going to be the same for everything except for the IV crush label. If we want it to be, we could change the foreground color, but I'm just going to do this for every label. Remember, each of these panels has a whole bunch of information to display. So we're going to want to reset all of it. Self.vix level label. We are going to reset. Self.current IV label. Reset. This is the what section? This is the metric section. Now we have the IV crush section. So we have self.pre-IV label. Reset. Self.post-IV label. Reset. Self.IV crush label. Reset. Now we have the, so that's our IV crush display. Now we have the option pricing display. Self.pre-call label. Reset. Self.post-call label. Reset. I think it's call loss. Yeah, call loss label. Reset. Self.pre-put label. Reset. Self.post-put label. Reset. Self.put loss label. Reset. Good. Now we do it for straddles. Self.pre-straddle. Reset. Self.post-straddle. Post-straddle. Post-straddle. Reset. Self.straddle loss. Reset. And that's everything in our straddle pricing. Now we need to do our P&L. So we do self.long P&L reset, self.short P&L reset. And we need to do the same for our strike and spot label. Self.strike label reset, self.pre-spot reset, self.post-spot reset. Same thing for the Greeks. So this is going to be spot strike. Good. IV crush. We can make this red if we want to. For the IV crush percentage, remember post the earnings event, we made it red. Should probably be conditional on the implied volatility, but we could do that later. Okay, last but not least is the Greeks. And I need to do the pre-delta. I need to do the post-delta. I need to do the delta change. I need to do the pre-vega. I need to do the post-vega. I need to do the vega change. Great. Now I need to reset the stock, VIX, and IV data, but that's easy. Stock data is equal to none. Self.VIX data is equal to none. And self.IV data is equal to none. Cool. If has attribute self IB app, we are going to kill it. We are going to say self.ibapp.historicaldata.clear. And effectively we can just log that we torched all of our data. So all we really did here was reset all of the labels in our user interface, clear the canvas, and delete all of the data from the historical data dictionary in our IB app implementation, our controller, and of course clear the data from our UI. It's really straightforward. We really didn't do anything particularly interesting there. Now we need to create, I think we should do the pricing functions. So we're going to use the Black-Scholes pricing functions to come up with the implied volatility crush. And, you know, I think there's a lot of confusion from people who watch my videos implementing the Black-Scholes model in the context of trading these options. They say like, oh, it's wrong, it's wrong, it's wrong. It's like, yes, it's a model and it assumes all these things and volatility is constant. That is literally what lets us back out implied volatility and use it as a measure of change in option value. I feel like there's kind of this like missed mark if you're kind of just suggesting, oh, it's, you know, the model's wrong. It's like, yes, the model's wrong, but we're using that to inform a linear approximation of change in portfolio value to capture an implied volatility crush effect. I don't know how else to explain it to those folks who, you know, just want to, I guess, preach the fact that the model is incorrect because it makes assumptions like every other model that exists. If we knew the true dynamics, we wouldn't need a model, but I'll digress. In any case, that's literally what IV is, right? IV is the volatility required to input into the Black-Scholes function to produce a price that we observe in the market, but I'll digress, or this is going to be a very long video. So let's begin by creating all of these pricing functions in this next section here. So really we did all the legwork. We have our user interface. We have connection, disconnect, clear. Now we need to start populating everything. So let's start with these pricing functions. Let's go ahead and create these pricing functions. I'll say def Black-Scholes call. Self, we need to take the spot, the strike, the time to maturity, the risk-free rate, and the volatility. And I need to calculate D1 and D2, but I also need a normal CDF. So I will say from scipy.stats, let's import norm. And then I will compute D1 as mp.log s over k. And then I will add r plus 0.5 times sigma squared times t divided by sigma times mp dot square root t. D2 is equal to D1 minus sigma times mp dot square root t. And the call price is going to be equal to S times the normal CDF, the cumulative distribution function of D1, of course, minus K times the discounted rate times the expiration of the normal CDF of D2. And then we can return that call price. Great. Now we can move on to the put, which which is exactly the same. We could use put call parity here too, but instead this is going to be what? K of, really I'm just going to take this second one here. We have the same D1 and the same D2. The only difference here is we have negative D1 and negative D2. And we're swapping the order because it's a put. So this is now not call price, this is put price. It's the only difference in the call and put formula. We could just use a linear approximation if we wanted to be lazy for the delta and the vega. Just do a small change in the volatility or the spot, keeping everything else constant. We should probably do it explicitly. Don't want to cut corners for you guys. So I'll say calculate delta self S K T R sigma, and the option type will dictate our signs. Fortunately for us, delta is really easy to calculate because it is just the same thing as the D1 in the Black-Scholes function. We just return whether it's positive D1 or negative D1. It's the cumulative distribution function of a standard normal of positive D1 if it's a call, negative D1 if it's a put. So if option type is equal to a call, then we are going to return normal.cdf D1. Otherwise, we are going to return negative normal.cdf negative D1. Fortunately for us, the vega position is going to be the same, so we can just go ahead and say def calculate vega, and this is going to be self S K T R sigma. And from SciPy stats, I'm just going to use the same D1 as before. I will return S times normal PDF in this case because we're going to partially differentiate the entire formula with respect to sigma. This is how we get vega. I'm going to use D1. Multiply this by the square root of t. Divide by 100. So that is going to be our vega value. So for a 1% change in volatility, that is the expected change in our option price. Awesome. Now we're ready to actually build a function to analyze the implied volatility crush. We have all of the pricing functions that we need. We can now go ahead and build the main function. So def analyze IV crush. Herein, we're going to have to check to see if we're connected first. So if self dot, if not connected, right? Or not self dot IB connected. So either the client, that is our user interface object, or the IB app object, which will be receiving the fresher information. If either of those are not connected, then we need to show some sort of error using a message box that we are not connected. And we can't get data for the analysis. So I will return here. We're done with this function if we can't access interactive brokers. All right, what if we can? What if we are connected to the server? Then we need to get what? The ticker from the user. So I'm going to say self.ticker var .get. I'll put everything to uppercase. And I need to get the earnings date string from the earnings date variable. That will tell me what I'm querying data around, right? I want to get days before and after the earnings event. So I'm going to get that from the dashboard, from the user interface that we just built out. All right. I am going to try, assuming they entered the date correctly, to format it as year by month by day, so that I can request data from the server. If they didn't enter it correctly, I'm going to get a value error. And I will show an error that we have an invalid date format. We need to use year, 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 month, month, day, day. Otherwise, we return. Otherwise, we can log a message that we are starting the Ivy Crush analysis for this ticker around earnings on, and we can also include self.earnings date. Very useful. We can call the clear function because we're about to paint a whole bunch of new information on the user interface, on the canvas. Now I'm going to create my start and end date. My start date is going to be self.earnings date minus time delta 10 days. The end date is going to be the earnings date plus time delta 10 days. Okay. I think we just need the end date actually. All right, we'll leave it there for now. Start date, end date, self.ibapp.historical data. Do we have anything saved in our dictionary? Well, if we do, we're going to clear it. That should be cleared here as well. Okay, now let's query some information from the server. How do we do this? Well, we already have our IB app created in our earnings trading dashboard. It's right here. So I can call self.ibapp and I can use it to make a request based on what the user provided to the ticker and as the earnings date. So I will say self.log message querying stock price data for self.ticker. Okay, the stock contract is going to be equal to self.create equity contract self.ticker. Remember, we created that function earlier on where we could pass a ticker to the function and it will return a contract for interactive brokers. If one is in self.ibapp.historical data, which it will not be, then we are going to delete it, but otherwise we can use it to handle our request. This is unnecessary. But if for whatever reason the server responds with data late or this or that or whatever, we're going to delete it here. Okay, we've already tried to clear it here and we've already tried to clear it here. But we're going to try to clear it again explicitly if the server somehow responds with it late. Let's request now the necessary historical data. I'm going to try to create a self.ibapp.historical data requests. The rec ID is going to be 1. The contract is going to be the stock contract. The end date time will be the end date that I had above. .strft time. We will make it the valid format of year, month, day, hour, minute, seconds. I think that's correct. Time is always very confusing. Year, month, day, hour, minute, seconds. I think that's correct. Okay. Duration string. We will make this 3 weeks. The bar size, we will make 1 day. And of course, you can make this whatever you want depending on what you're trying to analyze. Scroll on down here. What to show? Trades, of course. Use RTH? Sure. Format date? Sure. Keep up to date? No. We don't need to keep it up to date. Should we have chart options? Leave them empty. We will accept a general exception, and we will log a message. Error requesting stock data, and we will log the exception. We can show a message box too, I guess. And we can just say failed to request stock data. Show the exception to the user. That's probably fine. And return it. Okay. We can now wait for data, kind of like we did above with the connection. So effectively what I'm going to say is like timeout is equal to 15. Start time is equal to time.time. We'll get the current time. While one is not in self.app IBApp.historical data, and we still have time to wait, then we can just sleep. So we can just wait for the data to come in. And after we do that for this particular timeout window, yeah, we could use a loop like before, but I also wanted to use a while loop here. I mean, it's kind of cool, I think, to see two different ways of doing it. You could use a for loop and break like we did earlier, or you could just use a while loop here. The while loop is effectively waiting for the key to be in the historical data. Above with the for loop, we're just incrementing by what, 0.1 100 times for our sleep. And we can break if we see a connection. Here we're trying to check to see if the key exists, and effectively it's the same thing, but cool to see, I think, two different ways to go about waiting for data from the server. In any case, if one is not in the historical data after we wait this period, then what that means is we didn't get anything. So we failed to get stock price data. And that's a problem. And we're just going to return. So if one exists, what does that mean? That means this request with an ID 1 was successful. We received data to our historical data callback function, and it stored it in our dictionary with a request ID of 1. Great. So if this doesn't kill the function, we can then progress to the next step, which is processing the stock data and requesting VIX data. So I'll say stock data is equal to pd.dataframe. I'm going to create a data frame of the data that we have in our historical data dictionary. The date will, of course, equal pd.toDateTime. Stock data date makes it so much easier to work with dates and date ranges to create masks. So on and so forth. We'll say stock data.setIndex. The date is the index in place true. That means we are going to assign this directly to this stock data variable. Self.stockData is equal to stock data. Yup, because this was local and we want to assign it to the field in this class. And then I want to log the message that we were successful. So we received how much data? The length of stock data. Stock price data points. Wonderful. All right, now we can log that we are what? Querying VIX data. We're moving on to the next step. We need our VIX contract, which we get from our VIX contract function. Create VIX contract. We don't need any arguments because it's just going to return the correct parameters or the correct arguments in the contract for this particular security, which is, of course, the index, the VIX. If 2 is in self.ibapp, which it should not be, but if it's in the historical data, right, then we need to delete that as a key. If it doesn't exist, it shouldn't exist. We cleared it before, but if for whatever reason data came in late, we're going to clear it there, and we are going to try to make another request. This is effectively the exact same request as above. I'm going to copy it. Going to come on down here. Going to paste it. What is the difference? Request 1. Request ID 1 is the stock data. 2 is the VIX data. I don't want to use the stock contract. I want to use the VIX contract. And that should do it. The only thing that we need to change is the exception. We don't actually need VIX data, right, to analyze the IV crush. It's just a nice add. So maybe you don't have market data for it for whatever reason. We don't have to kill it right here. We can just log that we had an error requesting VIX data. And we can actually continue with the analysis, and we'll just put in maybe like a chart of the straddle instead if you have trouble accessing the VIX data. Okay. So now we can effectively wait for the VIX data. So what we're going to do here is we're going to say the start time, just as before, is equal to time.time. And while 2 is not in self.ibapp.historical data, this is what we did before, right? If we have some sort of wait time left from whatever time we allotted via this timeout, then let's just wait. Time.sleep is equal to 0.1. And yeah, if 2 is in self.ibapp.historical data, we've successfully received VIX data. And this is great because I can say VIX data is equal to pd.dataframe. I'll pass the ibapp.historical data to that data frame. I'll create a new data frame using the open, high, low, close volume and date. I will say the VIX data date is going to be equal to pd.toDateTime. This will be, of course, VIX data date. And the VIX data index is going to be, of course, then the date, and we will do that in place. Then we can apply this to the self.VIX data, the field in our trading dashboard class, and we can log the message that we received. The length of the VIX data, quantity of VIX data points. Great. Otherwise, what? We didn't get any data, but it doesn't matter. We can still continue with the analysis because we just need the implied volatility data. So VIX data is not available. That's totally cool. I'm just going to say self.VIX data is equal to none, and we can move on. Last but not least, we need to query the implied volatility data. If 3 is in self.ibapp.historical data, then again, we need to delete it. I don't know how it got there since we cleared everything earlier, but if we had a delayed request or whatever, we need to delete it. Now we can once again make the same market data request. I will use the request that we created above here for the VIX, because again, we can continue just with pricing information. I am going to use request ID 3 here. I'm going to use the stock contract again. because I want implied volatility data. I'm going to get then not trades, but option implied volatility. I will then do the same weighting scheme as the while loop I have here. I'll copy it. I'll come down here. I will paste it, and I will say while 3 is not in the keys for my historical data, I'm waiting on that implied volatility data, and if it comes, the loop is going to break. If not, I'm going to wait the entire period. And then if 3 is in self.ibapp.historical data, then I can now process this implied volatility data. So let's go ahead and handle this implied volatility data. It's a little different from the stock price data. We're going to have to do a couple of different things. I'll say IV data is equal to pd.dataframe just as before. I'm actually going to get the data directly here. I'm going to update the date such that it is a pandas date time to date time IV data date. So the date series is now a date time series in pandas, makes it much easier to work with. The IV data, we're going to set the index to the date column, and we will do this in place. So effectively, you know, when I set the index here, I am just telling it how to index the open, high, low, close volume for the entire series. This goes for the VIX, this goes for the stock price as well. And all that's happening here is I'm saying, hey, we have a dictionary of data. Let's turn it into a data frame. So we have series. These are the columns. These are different series. And I'm going to take the date series and turn it into a pandas datetime object. And then what I'm going to do is I am going to set that as the main index for the data frame, so that when I go to plot it, I can just plot the close, for example, by the index, the date. What is the raw IV? Well, the raw IV is just going to be the close. And I'm going to look to scale it. So effectively, if the raw IV dot max is greater than, let's say, 5, I am going to convert it to a decimal value. Divide it by 100. I'll say the IV data, the implied vol, is then equal to this daily vol as a decimal, the daily IV. And I'm going to log what? That I have received length of IV data points, and I have converted from daily percentage to annualized. Vol. All right. Depending on how you have your implied volatility configured is going to depend on how you handle your implied volatility here. If it's daily, you are going to need to scale this by 252. If it's not, then you are good to go and you can use it as annual vol. Okay, just make sure that you're using the correct units for the volatility, such that when you actually look at the IV crush, you're not looking at some sort of 1,000 implied volatility because you've scaled 40 by the square root of 252. Make sure that you are using the correct units of volatility. It's going to depend on whatever you like, but in this case here, we can even handle or try to handle dynamically. If you've queried it in terms of daily units, we can try to put it back into annual units. But again, this is going to depend on how you have your TWS configured. So this part, I need you to also review the vol values you observe. Don't just blindly copy this section. I don't know how you have your TWS configured. So make sure you're observing the correct values. In any case, Otherwise, we're just going to say the IV data is the implied vol data. This is equal to the raw IV. And in this case, we could annualize it here as well. This is just going to be whether or not we're observing it as like percentage versus decimal. And then we're going to turn it into a decimal value and then scale it if we have to. So it's just going to depend on how you're receiving it from Trader Workstation. So then here I'm going to log the message. What? Received length IV data points, annualized vol. All right. Why didn't I scale these by 252? Well, if I go to my Trader Workstation like I did at the start of this video, you will see that my vol units are in terms of annual vol. So I don't need to scale it. If my vol was daily, then I would have to either convert it from percentage to decimal or use the raw vol and scale it by mp.square root 252. And I would have to do that here, and I would have to do that here. But mine is in terms of annual vol. And if you're just trying to follow along here, you can leave yours in terms of annual vol as well. But if you want to leave it in terms of daily vol, you have to scale by 252 there. Okay. So the IV data for this particular earnings trading dashboard UI will equal now this data that we've prepared. And we have this annualization factor of 1. And I can print this or log this, but it really doesn't matter because I didn't annualize it here. Effectively, even this is just kind of a little redundant because I didn't do the conversion. I'm assuming that it's coming in terms of annual vol. You just have to know how you have your TWS configured. So I am effectively just going to log that we have successfully preprocessed the implied volatility data. And if not, then I'm just going to say that we don't have it available to us. All right, fantastic. So that is going to do it for this portion. This is how we request the data. Now we need to actually perform analysis on the data that we receive. So I'll say self.perform IV crush analysis. And we can now write this function to perform the IV crush analysis. So we're really almost done now. We just have 1 or 2 more functions to build. We just got to perform the IV crush analysis, update all of the labels, and then draw the data visualizations, and we'll be ready to run the app. So let's start by logging that we are going to be performing this IV crush analysis. Looks like I forgot to include self here. Okay. The earnings date herein is just going to be the earnings date from the user interface. And we're going to want to get the pricing information around the date. So what I'm going to do is I'm just going to get the pre-earnings date as the earnings date minus time delta of 1 day, and the post earnings date as the earnings date plus the time delta of, again, 1 day. And then the stock dates themselves are going to be from the stock data's index, right? We pre-processed the stock data above. We made the date a date time pandas series, and we're going to get that index right here. And now we can actually use this mask, this idea of a mask, to essentially find the pricing information for that window we are interested in. So the pre-date actual is going to be the last trading date before the earnings date. So this is like on or before the date of the earnings. So I will say stock dates, and I'm going to create this mask. Stock dates where we have any time that is less than or equal to the earnings date, we will take the max. That is the date that is closest possible to the earnings, and it could even be on that earnings date, and we're going to get the data specifically for that time period, or I should say the date specifically for that time period. Okay. Now, if the length of that data, so effectively I'm saying if the length of that data for this particular mask is in fact greater than 0, that is what we're going to use. We're going to use the max date here. Otherwise, we can use the min date. That looks good. And we're going to do the same thing for the post date. Okay, it's just going to be greater than instead. So the post date actual is equal to the same mask, but instead of less than or equal to, it's going to be greater than. So this is after the earnings date. So we will do .min, right? Effectively, what you can think of this as is, let's think of this like a timeline. You have this earnings event, right? You have before the event occurs. So it's leading up to the event. We want the max time leading up to this event. That's the pre-date actual. That's what we have here. So leading up, we want the max leading up to that event date. Then we have the post after the event. We want the min closest possible to that date. So in terms of time left to right, we want to get the max before the event and the min after the event. That's how we can do this pre and post game analysis. And this is exactly the same, right? If the length of this stock dates with this particular mask is greater than 0, otherwise we are going to get the, I believe this would be the dot max then. That would be the dot max. Okay, so again, think of it like a timeline. We're going to create this mask, and we're going to look for the max date closest to the earnings date for the pre, and the min date closest to the earnings date after. Notice, it is not greater than or equal to. It has to be after the earnings date. Okay, because we're doing this analysis on market close. Cool. So that's the pre-date, that's the post-date. We can log the earnings date. We can log the pre and post-date now. So I will call this the earnings date. The pre-date will be the pre-date actual, and the post-date will be the post-date actual. We can, of course, format that maybe a little nicer. .str will do year, month, day. And then we can use that formatting for each of the pre and post. And of course the earnings event itself. Now we need to use these dates to find the relevant pricing information, the implied volatility information, and the VIX information. Effectively, what we have here is the date of the earnings event, the date after the earnings event, and we have pricing information indexed by date. So we can just get that pricing information for each of the pre and the post earnings event. Cool. The pre-stock price is then going to be equal to what? Self.stockdata.loc. We're going to get the post date actual, find the open. We are this is really the no, we need the pre-date. So this is going to be the pre-date actual, and we want the close. This is the last price that we observe before the earnings event takes place. This is the pre-stock price. So we get the close. The earnings event occurs. We need to get the open. So we use the post date. We find the open. And we get the post stock price. We get the post close. And we get the close. Then we can take the average. All right, what do we do here? We used the earnings date that the user gave us to find the pre and post earnings day from the time series of data that was given to us from Interactive Brokers. So we're going to effectively find the last possible price for the stock before the earnings date. Then we're going to find, after the earnings happens, the opening price. So we're getting the price closest to the earnings event on either side of the earnings event as registered by the market. At this point, we can log a whole bunch of information. I'm just going to log the overnight earnings gap to open and the close to average. So I'm going to say self.log message. I will be effectively logging the overnight earnings gap to open. And this is going to be the overnight gap to open is the post open minus the pre-close which is just going to be the pre-stock price. And then we are going to divide that by the pre-close. And then we're going to multiply the whole thing by 100. So effectively, we're getting the last seen price in the market. The earnings event happens, and we're going to compute the overnight gap to open, the percent change from the close to the open after the earnings event occurs. We can also compute the total move relative to the post-stock price and the pre-close. So this is the close average. So we could use the post-close or the post-average. In this case, I'm just going to use the post-close so we can compute the close-to-close total move as a percentage. So I will just say total move is equal to, we will say post-close minus pre-stock price divided by pre-stock price times 100. And then I will log that as well as the total move percentage close to close. And that'll be the total move. This is where you can, really check out a whole bunch of interesting measures, how things changed before and after the earnings event, also in terms of volatility and whatnot. But in this case, I'm just going to log these two quantities. You can choose to log whatever you like, but we're going to be updating the dashboard with so much information. I'm just going to leave it at this point with these two measures, the overnight gap to open and the total move. Now we're ready to actually update all of this information on our user interface. So I will say self dot stock price label config, and I'm going to make the text equal to formatted string. And I will say post stock price. I'll update now the VIX data. So if the VIX data is not none, then I am going to make the VIX dates equal to self.vixdata.index. The pre-VIX date is equal to the VIX dates, and of course we're going to use this same window here, the same mask that we had earlier as the pre-earnings date. We will get the latest possible point up to the earnings date. If the length of this particular mask is greater than 0, otherwise we are just going to get the min and the post VIX date is going to be the same thing, but now we're getting what? The item closest to the earnings event on the other side of it. So this is after the earnings event occurs, so it's going to be the min if the length of the VIX dates for this particular mask is greater than 0. Otherwise, we will get the max. So really, anytime we're using this mask, we're just creating a vertical line for that earnings event, and we're saying, hey, let's get the closest data before and the closest data after. That's why we're using this min and max. And if it yields anything, then great. That means we have data there. If not, let's get the next best point, which is going to be the max and the min. Okay. The pre-VIX value itself, now that we have these dates, is going to be given by the pre-VIX date. The close. And the post-VIX is going to be given by the post-VIX date and the close. We could do the open here. It's entirely up to us. For consistency, I'm just going to plot the close. Okay. And, you know, here what we can do is we can log it if we so choose to do so. So we can log that the pre-earnings VIX is this, and the pre and the post VIX is that. Otherwise, you know, we can just set the VIX label to be not available. Remember, we don't need the VIX data for this analysis technically. We just want the pricing data for the Black-Scholes function and the implied volatility crush. We would need the implied volatility data in order to do that. But of course, if we have that data, then here we can just plot in terms of the config. A formatted string will do the post VIX. After the earnings event, we'll plot the post VIX level there. All right, very good. That is the VIX level label. And that should be it for this section on the VIX data. Awesome, we're now ready to move on to the implied volatility data, and it's gonna operate in a very similar capacity here. So, you know, effectively what we're gonna do is just say if the self.iv data is not none, then we've queried it successfully, and we need to access the dates. So I'll say IV dates is equal to self dot IV data dot index. That's where we, of course, push the pandas datetime object to the IVOL data frame index. And again, I'm going to create this pre-IV date as the IV dates with this mask pre-earnings. IV dates less than or equal to the pre-earnings date. I want the max possible value, and if the length of such a mask is greater than 0, I'm good to go. Otherwise, I want the min value. Cool. I do the same with the post IV date. If the IV dates are greater than 0, then I do dot min. And if the length of IV dates is greater than 0 for this mask, then I will set it as the min. Otherwise, I will do the max. And that should be the correct pre and post date. Now I can get the pre-IV as the IV data.loc. I'm going to find the pre-IV date and the implied volatility. And I will do the same with the post-IV and the post date. Post-IV date and the implied volatility. Cool. I can plot this, or I can not plot it yet. I'm gonna log it. So I'll just log that I have the pre-earnings IV as pre-IV, and I will log that I have the post-IV as the post-ID, as the post-IV, and now I can set the label as well. So I can do, I need to calculate the vol crush. So I will say IV crush is equal to pre-IV minus post-IV divided by pre-IV times 100. That is my percent change in volatility. Now I can set that IV crush label. So effectively, I'm going to say self.current IV label is going to be configured as, we have text F, I have the post IV. Yep, that's going to be the current IV label in the current metric section. Self dot, we need to do the pre-IV label. So we will config that to have the text of the pre-IV value. The post-IV label will have the text of the post-IV value. And I think that should be it. Nope, we need the IV crush as well. Self.IV crush label.config, text is equal to, and this is going to be the IV crush. Fantastic. So that's all of the labels there. I can then look to work on the pricing for the call put straddle and then update the labels associated with the pricing information. So we now need to calculate option prices. So I'm going to say let's try days to expiry is equal to int self dot days to expiration bar dot get. So this is in our entry form in our user interface. We will accept a value error and just set days to expiration equal to 30 if that's the case. I think it's reasonable to do this because the duration of the contract is just going to impact the actual value of the vol crush. It's not going to impact the relative performance in terms of Vega. So yeah, the option value, if we fix it to 30, is going to be wrong, but we're just approximating the Vega effect anyway on the option, so I don't think it matters all that much. If anything, your theta effect is going to be, it's going to help you if the expiration should be shorter. But again, I'll digress from this so that we can continue. So I'll just say days to expiration bar dot set 30 if we have to default it because the user did something wrong. Okay, so now what we can do is we can just start to compute these option pricing, or these option prices, I should say. Time to expiry is equal to days to expiry divided by 365. And the at the money strike is just going to be equal to the pre-stock price. This is for simplicity. A good extension you can try to work on yourself is to try to write code to allow the user to enter their straddle strike price. I'm just going to use the pre-stock price for simplicity. Again, we're just looking to capture that net Vega effect to see if the earnings event allowed you to capture the premium or not. And that could be because the option expired that week, or not necessarily even capture the premium, but capture the implied volatility crush effect in terms of your short Vega position. So now we can just go ahead and calculate these prices. The pre-call price is equal to self.Black-Scholes call. I need to use the pre-stock price, the at the money strike price, the time to expiration, the risk-free rate, and the volatility, which is going to be dictated by the what? The pre-IV. Now we need to do the pre-put price. This is equal to self.Black-Scholes put. We have the pre-stock price. We have effectively the exact same parameterization, the exact same arguments as the Black-Scholes call. And we're going to do the same for the post-call price. We'll call self.Black-Scholes call, and then the only thing that changes is the IV. We're going to use the post-IV. And we're going to use the post-stock price. Post-stock price. And that is also going to be true for the post-put price. We'll do the Black-Scholes put. And we're going to use the post-IV. And the post-stock price. Everything else remains the same. Yeah, we can decrement the time to expiration by a day if we want to account for a theta value, but I'll leave that up to you if you wanted to consider the change in time. In terms of the theta value of your contract, feel free to do so. The pre-straddle price is equal to the pre-call price plus the pre-put price. The post-straddle price is equal to the post-call price plus the post-put price. Cool. Now let's compute the price changes. Dollar change in call is the post-call price less the pre-call price. The put change in dollars is equal to the post-put price less the pre-put price. And of course, the straddle change in dollars is equal to the post-straddle price minus the pre-straddle price. Very good. That means the long straddle P&L is equal to the straddle change in dollar, and the short straddle P&L is equal to negative the straddle change in dollar. We now need to calculate the delta. So the pre-call delta is equal to self.calculate delta. We need to give it the pre-stock price We need to give it the at the money strike price. We need to give it the time to expiration, the volatility,
market data
which
connection
is,
lost.
Oh no. We need to give it the pre-IV. All right.
Market data connection reestablished.
All right, nice. We're back online. We need to give it the pre-IV here because this is the delta before. So this is the pre-call delta before the earnings event. So we give it the pre-IV, and the option type is just going to be a call. So I'm going to leave it as a default argument. That should be good for the pre-call delta. What about the pre-put delta? It's the exact same thing, but we have an argument then for the option type. So the the pre-put delta is equal to self.calculate delta. We're going to do the exact same thing, but we also need to tell it that it is in fact a put, not a call. Pre-call delta, pre-call delta. Yeah, that looks good. Now we need to do the straddle delta. So the pre-straddle delta is equal to the pre-call delta plus the pre-put delta. And now we can do the same thing for post. So the post-call delta is equal to the calculate delta function, but now with the post information. So it's the exact same thing we did with the Black-Scholes. We used the post implied volatility and the post stock price. Now we're using the post implied volatility and the post stock price. Same thing for the put. We just need an argument that we are working with a put. And this is going to be the post straddle delta, which is the post call delta plus the post put delta. Now we can calculate the change in delta, the delta of the delta. It's going to be the post straddle delta minus the pre-straddle delta. Good. And we're going to do the same thing now with Vega. So the Vega is going to be the pre-call Vega, which is equal to self.calculate Vega. And here we're just going to use the pre-stock price. We will use the at the money strike price. We will use the time to expiration that was given to us by the user, the risk-free rate, and the pre-implied volatility. And we will do the same thing for, it really doesn't matter if we do it for the put. It's the same Vega, so I'm just going to use 2 times the call. So I will say, in this case, the pre-straddle Vega is equal to 2 times the pre-call Vega. And then the post-call Vega is going to be the exact same thing as this, but with the post-implied volatility and the post-stock price. So post-IV and, of course, the post-stock price. Good, and that means the post-straddle is, of course, going to be, the post-straddle Vega is 2 times the post-call Vega. And then we can compute the Vega change as just the post-Vega for the straddle less the post-Vega for the, or the pre-Vega for the straddle. Awesome. And now we're ready to actually update all of the labels, and then we just have to draw the figure on the canvas and we'll be all set. You know, I just realized here that we have been writing this option pricing code in this conditional statement. So we have self.iv data is not none. And really what we should have been doing this entire time is writing from this log outside of the if statement. So what I'm going to do is I'm going to highlight all of this code and I am going to press Shift Tab and I'm just going to tab it out one level, and that is going to be the intended effect. Essentially what I'm saying is I don't need this pricing information to occur only if IV data is not none, I'm going to have that outside here. And of course, I can include some sort of like conditional statement here to handle a case where it is none. But in this case, we're just going to leave that where it lies and continue to move on here. So again, we just kind of tabbed out from this pre-earnings IV, post-earnings IV log message. This is right where we calculate the IV crush percentage. And from there, we can just continue to march on down where we were computing all of our option prices, or all of the option pricing information. Okay, so not too big of a change there. But now we're just going to start to update all of the labels. So I'm going to say self.precall label.config. And in this case, I'm going to say text is equal to, we'll have a formatted string here, precall price. And I'm going to round it to 2 decimals. We're going to be doing this a lot, so I'm just going to copy this .config statement and do this for all of the labels. So self.postCall label config, we're going to use the post call price. Then we have self. Or I guess we can do a custom color now. So we could say call color is equal to green if the call change in dollar is greater than 0. Otherwise, we'll make it red. And then we'll say the call loss label, and we will paste the .config there, and we'll make the foreground color equal to the call color conditional. That's great. And we're just going to do the same thing going down for the put and the straddle and everything else. So I'm going to copy this. I'll paste this. We'll make this the pre-put. We'll make this the pre-put price. So pre-put price. This is the pre-put label. This is the post-put label. This is the post-put price. Instead of a call color here, we're going to do the put color. And this is going to be the put change in dollar. And then instead of call loss, we are going to have put loss label. And this is going to be the put loss, or the put change dollar. This should also be the call change dollar here. Call change dollar. And then this should be the put color. Cool. We'll update the straddle prices in the exact same way. So here, instead of pre-put label, it's pre-straddle label. This is the post-straddle label. This is going to be the straddle color. And of course, this is going to be the straddle dollar change. This is going to be the straddle dollar change. This is going to be the straddle color. This should be the straddle loss label. And then of course, instead of the post put price, it's going to be the post straddle price. And not the pre put price, but the pre straddle price. Great. Now we have to update the P&L for the long straddle and the short straddle, those labels. So the long color is going to equal green if the long straddle P&L is greater than 0. Otherwise, it will be red. And the short color is just going to be the same thing. So if the short P&L is greater than 0, we'll make it green, otherwise we'll make it red. Okay, and it looks like I have N here instead of P and L. So let me just go ahead and find this. So I've defined it as short straddle NL, this should be PNL. And then I'm gonna come down here and make this also PNL. All right, so that's the only place that we made that definition for short straddle PNL. So maybe you caught this earlier, but up here, roughly line 670, we defined it as the negative change in dollar for the straddle. So we're going to come on down here and use that to decide the color of that label. And then what I'm going to do is I am going to effectively update the label now with the P&L numbers and that color. So long P&L label .config. I could paste the .config again. So I'll copy it and I'll paste it. Instead of the straddle change in dollar, it's going to be the long straddle P&L. And I could also add a $sign before it if I want to make it a little more interpretable. I can also add the percent change. I'm just going to leave it in terms of the P&L. And I'm also going to add this foreground color of the long color. Same with the short color, short P&L .config. And I'll just paste the config. And I will make this the short P&L, short straddle P&L. And then this will be the short color. All right, very cool. And then the strike price label is just going to be, no color. We can just make this the at the money strike price that we had earlier. We could do the same idea here with the pre and post spot. So we have the pre-spot color as black and the post-spot color as green or red based on the movement. So I'm just going to make the post-spot color equal to green if the post-stock price is greater than the pre-stock price. Otherwise, we'll leave it as red. And the labels are just going to be what? Self.pre-spot is going to be configured as, and I'll just copy this. Config, it's going to be the pre-stock price. And the foreground color, we can just make it as, let's just say black to default. And then the post-spot price, we want that to take on the color, right, of the movement. Based on whether or not it moved up or down, we'll make it green or red. And that's going to be the post-stock price here. Cool. We also need to update the Greeks. Again, we could use colors here. It's going to be entirely up to us. I'm just going to leave it in terms of, or I'll just make the absolute change red or green. So the delta color is going to be green if what? The absolute value of the post-straddle delta is less than the absolute value of the pre-straddle delta. Otherwise, we'll make it red. And we could say self.pre-delta label. We will configure it. No color for this one. This is not a change. This is the pre-delta specifically for the straddle. And then we're going to do the post-delta. The post-delta label. And we will make this, we will configure it with the color. So here we're going to rock the delta color. And this is going to be the post-straddle delta. The change in our delta. Oh, I'm sorry. No, we don't want to use the delta color here. We only want to use it for the absolute change, right? That's the delta color. Yeah. And that's going to be the delta change. So if the absolute change in our delta is negative, it'll be red. If it's positive, it'll be green. And now we'll just do the same thing with Vega. And then all we have to do is create our visualizations and we're done. So Vega color is equal to red if the Vega change is less than 0. Otherwise, it'll be green. The pre-Vega label, we are going to configure it with no color. And then I am going to make the pre-straddle Vega the value for that label. Same thing with the post Vega label. I am going to do the same thing. The post Vega, the post straddle Vega. And then the Vega change label, I am going to effectively throw in the Vega change, and I will consider the foreground color as the Vega color that we have here. And that's all of the labels to update on the dashboard that I can see. Now it's time to create the visualizations. And we need to build this function. So I'm going to say def create visualizations. And now we can start to build the charts for our window. And this is not going to take nearly as long as what we had just done. So once we build these charts, we are going to be all wrapped up and we will be ready to test our application. Let's go ahead and wrap up by creating this last function to plot the price path, the implied volatility path, and the VIX path. And we can go ahead and debug our application because no doubt we made a mistake along the way. In any case, let's go ahead and wrap up here. So we're going to clear this axis. We are going to clear this one as well. And we will say if self.ax1 twin is not none, we are going to try to remove it. Effectively, we're just clearing our data here. And if we get an exception, we'll pass. In any case, we will set this equal to none. Great. Let's start by plotting some information. This is going to be plot 1. This is stock price and IV around earnings. So I'm going to say earnings window is equal to pd.dateRange. The start is going to be self.earningsdate minus the time delta of 5 days. So we're going to go 5 days back. You can make this whatever you want, assuming you've queried enough data from Interactive Brokers. The end date is going to be the earnings date, of course, plus a time delta of 5. The frequency is naturally going to be days, and that is our earnings window. The window for our stock is going to be dictated by the data frame and the index. So the window for the stock that we are going to plot is equal to self.stockData. We're going to access specifically this window of self.stockData.index where it's greater than or equal to the earnings date less the time delta of 5 days. And of course, where we observe less than or equal to the earnings date plus a time delta of 5 days. This is just saying plus or minus 5 days around the earnings window. Okay, now we can plot everything. Self.ax1.plot, we're going to do on the x-axis the window of the stock, the index, that is the date. The window stock, the associated close for those dates around the earning window. We will style it nicely. We will give it a good line width. We will give it a label of stock price. We will add a vertical line for the event date itself that occurs on the earnings date. We will make that red. We'll make it dashed for interpretability. We'll make it a little transparent. And we will label it the earnings date. We're going to set the X label to be, of course, the date. We are going to set the Y label to be the stock price in dollars, right? Because that's the currency for our contract. We can make that blue. let's set the label color for the tick on the y-axis to be blue. And let's set the overall title of the plot to be stock price around earnings. Now we're going to have a twin axis here with implied volatility, right? So just keep that in mind. Let's also add a grid. I think it looks nicer with the grid. You can choose to remove it. I'm going to let the alpha value of the grid be 0.3, so it's relatively see-through, and I'm going to put the legend in the upper left-hand corner. Okay. We're also going to plot the implied volatility, but on a twin y-axis. So this is going to be on a twin y-axis. We will say if self.iv data is not none, and the length of the IV data is in fact greater than 0, the window for the IV is equal to self.iv data, and of course this is going to match the exact same window that we had above. So I'm going to copy this, I'm going to paste it in here, and instead of stock data, I am going to be using the IV data, but it's the same window. Okay, so we're using the IV index, the IV data, and the IV index. That's going to be my window IV. And now I'm going to say if the length of the window IV is in fact greater than 0, we can just say self.axTwin is equal to self.ax1.twin axis. And now I can say IV percentage is equal to window IV implied vol, and we're going to scale that by 100, bring it to a percent. And I will finally be able to plot this now as ax1 twin.plot window IV.index, right? That's our date range. We have the IV percentage, and of course we can style this nicely. We'll give it a nice line width. The label will be the implied. I'm gonna label it as the annualized implied volatility. Then I can say, let's set this twin to have a Y label of implied volatility. This is annualized implied volatility for that date range. Can make it look nice if we give it a color. We'll make it green. And I will set the tick params on the y-axis as well to have the color green. And then ax1 twin, I'll put the legend in the upper right. Okay, that'll do it for the implied volatility data. Now we're ready to plot the VIX data. So for the VIX data, it's roughly the same thing as well. We have that same window, right? So if there is VIX data, then we need a window for the VIX, self.VIX data, and this is going to be the same mask that we had earlier. I'll just copy this, and I am going to paste it down here, and I'm going to use the VIX data instead of the IV data. And then I can just go ahead and plot all this information on that second axis, right? This is not a twin axis now. This is just going to be a second axis. Self.ax2.plot window VIX.index window VIX close. So that's the date and the VIX close. We'll make this in purple, and we'll give it a nice line width. And the label, of course, will be the VIX. The vertical line we will add as well to this plot for the earnings date. So x is equal to self.earnings date. The color, we can make it red. We'll make it dashed. And then the alpha, we'll make it a little transparent. The label will be the earnings date. We will set the X label to date, set the Y label to VIX level, set the title to VIX around the earnings date, and then set the grid to be the same style as the other plot for consistency there. And then we will also display the legends wherever it sees fit. All right. If there isn't any VIX data to show, we could technically plot the straddle prices as well to show the comparison. So for whatever reason, if we don't query VIX data, we could, instead of displaying the VIX path, we could show the straddle, the net change in straddle position as a chart. I would certainly encourage you to do that if you are interested. I'll leave it as essentially an extension. So here effectively it would just be else, and then within this plot the straddle charts instead with the relative value. The relative value change in pre versus post. And really all of the heavy lifting is done for you because we know what the implied volatility is. We wrote all the pricing functions. We know the pre and post stock price. We know what the straddle was priced at before and after. It shouldn't be too difficult to come up with the straddle points and actually plot those charts, which would be a nice extension if we don't have access to VIX data. But other than that, assuming that we do have access to VIX data, then we can just format the charts so that the dates are displayed in a nice fashion. So I'll say axis 1, tick parameters. We will say axis is equal to X. We will have a rotation of 45 degrees. And I need to pass here if I'm going to have a else statement there. So the X1 will have a 45 degree rotation for the dates, so they're interpretable. And then if self.vix data is not none, then we will also rotate those axes, those dates as well. So we'll do tick params, axis is equal to X, and we will do a rotation of, again, 45 degrees. And now we can just do self.fig.tight layout, and we can just do self.canvas.draw, and we will effectively be drawing all of those charts on our canvas. And that is going to do it for this create visualizations function. We are now ready to tie all of the pieces together. Look at this. We've written almost 1,000 lines of code together with no AI. This is just like the good old days, learning how it was intended to be. So let's go ahead now and create our main load function, and we can debug our app and see if everything works. Let's create this main load function now. I'm going to back out of the class. We are effectively done writing code in that earnings trading dashboard. So now what we're going to do is say def main, and we are going to say root is equal to tk.tk. Remember, in our constructor, what do we have here? We have to pass a root, a tk window root, so we can draw all of these assets on top of it, all of these widgets. That's exactly what we're doing here. We're going to create this root. Then I will say app is equal to earnings trading dashboard. I'm going to pass it this root from tk.tk. That's exactly what it's expecting. And I will call root.main loop. Now I can say if name is equal to main, let's go ahead and run this main load function. And that is going to do it. Now let's give it a run and see how it works. All right, moment of truth here. I click run, and it looks like I have an error on line 599. So let's go there. On line 599, it would appear that I have an unmatched parentheses, but that is not the issue. It looks like I am using quotes in a formatted string, so I need to do this more correctly here. I need to format this with single quotes instead, so it doesn't look to close out the quotes of the string in my formatted string statement. Okay. Give it another run. Whoa, look at that. She ran correctly. It looks like all of the labels populated correctly. Let's go ahead and see if we can connect to Interactive Brokers. See if my Interactive Brokers server is still up. Looks like I'm getting unable to connect. Client ID is already in use. Oh, looks like I have my other client running still. Let me go ahead and close this. I will close this. Let me go ahead and close the other client. All right, now let's give this another shot. Give this a run. We got the dashboard up here. Let me connect. Looks like we've connected successfully. Let's see what happens when I click Analyze IV Crush. All right, looks like we're getting a whole bunch of information here. And it looks like, yep, I'm getting the stock price, the VIX level, the current IV. I have my pre-earnings IV and my post-earnings IV and the percentage of IV crush. Okay, looks like I'm getting a couple of errors here when it comes to the perform IV crush function. See what we got here. The calculate delta is missing one positional argument sigma. So let's go to the call delta and the put delta and see what we got going on there. This is on line 672. So let's go over to line 672 here. And it looks like it is expecting the call as an argument. Let's see how we defined the delta in terms of the option type. We have 1, 2, 3, 4, 5 parameters with the option type. It should be defaulting to a call. Let's see what we provided the function. We're missing the an argument. We're missing the risk-free rate. So we need to add self.risk-free rate as well after the time to expiration. So I will add that now to that delta function, the pre-delta functions, and the post-delta functions. All right, that should do it. Let's go ahead and restart this guy here and see what else we come up with. So gonna run this guy again. Analyze the IV crush. All right, we got some good information here. Looks like we're querying everything correctly. I think if we look at our terminal here, we're coming up with this unknown color read. It looks like that should be red. That occurs maybe on line 724, it would appear. So let's go over to line 724. And yep, I write it as read here. So we'll leave that as red. Let's give this another go. Give this a run. Give this a connect. Analyze IV crush. All right, and it looks like now we're getting somewhere. We're getting the delta as well. It looks like the implied volatility needs to be scaled to be in terms of a percentage unit. So we can make that change, and it looks like the post earnings IV is incorrect here. It should be significantly lower than the pre-earnings IV. So we can remedy that in a moment. But before we do that, let's go ahead and fix this error here. It looks like we have an error in terms of the line width. This is on line 780. I just spell it wrong. 780 is line width. There it is. Line width. Give this another run. Let's see if we can get it to the charts. Give this a connect. Give this an analyze IV crush. Would you look at that? All right. We are getting the correct chart information. We're getting the correct vol information. This is exactly the same chart we saw in the demo at the start of the video. And now we just have to fix this pre and post earnings IV. And that should be everything. If we take a look here, looks like the pre-earnings call and the post-earnings call are both reasonable. And the long and short straddle P&L are in the correct direction, right? The long straddle P&L lost money. The short straddle P&L made money. We just have to scale the vol in terms of the correct units. So I've observed the main source of the error. It comes from where we create the date masks for our pre and post implied volatility and for the pre and post VIX around the earnings date. So what we've done here is effectively what we're trying to do is apply a mask where we have this vertical line and we're going to look for the VIX data closest before the earnings event and after the earnings event, and the same with the implied volatility data. But what I had forgotten to do is change the pre to the post when we're looking for the closest data on the other side of the earnings event. So for the VIX, this was on line 618 or around 618 for your program, where we look at the pre-VIX date and the post-VIX date. This needs to be greater than or equal to, and this should be the post-earnings date. And the same thing for this mask over here. This is for the post-earnings date. Cool. And then we need to apply the same fix down here for the IVs, for the implied volatility. So this is going to be greater than or equal to the post-earnings date. And this is going to be greater than or equal to the post-earnings date. Fantastic. Now, if we go about running this guy here, we should see the correct values that we saw at the start of this video. If I hit Analyze IV Crush, then yep, we get the stock price, the correct VIX level, the correct implied volatility, and in fact, we realized the correct long-short straddle P&L, the correct changes in call and put value, the correct end-of-day spot price, the average spot price, and the correct percentage of IV crush. It doesn't actually matter if the implied volatility is scaled by 100 in terms of a percentage. The proportion in terms of the change is going to be the same, right? It's just a linear operation. So that is effectively the earnings event trading dashboard. We built it together from scratch, almost 1,000 lines of code, just like the good old days. I will leave it to you if you would like to clean this up a little bit, add some more colors. If you want to round these decimals, you can round them to maybe 2 places, format them in terms of a percentage, so on and so forth. But in any case, that is going to do it for this video. We wrote 1,000, almost 1,000 lines of code to build this event trading dashboard. And that's going to do it for this video on how to build an earnings event trading dashboard. I hope you enjoyed. I hope you learned something. This video certainly took a lot of effort to create. So please like, comment, subscribe, share. It helps me out tremendously. It is always greatly appreciated. Join our Discord if you want to connect with me and other quants in the Quant Guild community. Check out quantguild.com if you'd like to master your quantitative skills. Other than that, thank you so much for watching, and I will see you in the next video.